Hi, welcome my dear students. Today we are going to discuss some problems on similar triangles, right? Yesterday we have discussed the criterion, the conditions for similarities. To prove two triangles are similar, one is AAA similarity that can be reduced to AA similarity, second one SSS similarity, third one SAS similarity, right my dear students? Now, based on those results, we are going to discuss now certain problems, right? You see, Nana, my dear students, here, the first problem, the perimeters of two similar triangles are 30 centimeter and 20 centimeter respectively. If one side of first triangle is 12 centimeter, find the corresponding side of the second triangle, right? My dear students, see here, the perimeters of two similar triangles are right 30 and 20 centimeter respectively. If one side of first triangle is 12 centimeter, determine the corresponding side of the second triangle. You see, my dear students, whenever we are having two triangles like this, whenever we are having two triangles, A, B, C is one triangle, another triangle is something like this. You are having here like D, E, F, right? Fine. Fine. Now you see, my dear students, once they are similar, that means once they are similar, that means you know that AB by DE is equal to BC by EF, that is equal to AC by DF. They are all equal to some constant. Now if you take their perimeters, of course, then that becomes AB plus, right, my dear students? Now see here, once these two triangles are similar, you will be having like this. Now, from this what we will be having, let us discuss very clearly, my dear students. AB by DE equal to K. That means AB equal to K into DE in this, right? And similarly, you are going to have BC is equal to K into EF like this, right? And you have here AC, right? AC is equal to, now AC is equal to K into DF, right? This is what you are having like this. Now once you have the things like this, now AB plus BC plus AC, AB plus BC plus AC, right? They told that the perimeters of two triangles are 30 centimeter and divided by, right? This is what perimeter of the first triangle and perimeter of the second triangle. That means DE plus EF plus DF. This is what we are having here like this, right? Fine. This their perimeters, right? What I try to tell you is this is also is equal to K. This will be in the same ratio. Once the sides, what the point I want to tell you is here now AB is equal to, now you have got K DE. K if you take common, DE plus K into EF plus DF. You are having like this. Whole thing divided by now DE plus EF plus DF like this. This cancels. That means you have got K. That means what I try to tell you is K is nothing but what actually AB by DE is equal to BC by EF, that is equal to AC by DF like this. That means the ratio of the sides is equal to the ratio of their corresponding perimeters. That is the point I want to mention you now. Okay, very good. After getting these things, now see, my dear students, what we will be doing is the ratio of their perimeters. The perimeters are they given. Now we proved that the perimeters are in the ratio. See here, this is what the perimeters are in the ratio of their sides. Now the perimeters of two triangles, they given they are similar. They given that 30 by 20, and if one side of first triangle, that is 12, they given. Okay, determine the corresponding side of the second triangle. That we don't know. Let us take it as lambda like this. From this, you see, my dear students, 30 into lambda is equal to 12 into 20 like this. Now 0 here, 0 cancel, 3 1, so 3 4s like this. Lambda is equal to 8. You will be getting like this. See, lambda is equal to, beautifully we have got 8. Therefore, the corresponding side of the second triangle is nothing but what? 8. If one side is 12 means, then the corresponding side of the other triangle, that means they given that one side is 12 means, then it become 8 like this, right, my dear students? Simply these figures I have drawn only for our understanding purpose, not to the scale, right? Now we have the second problem, which is 8.2 exercise second problem, right? My dear students, 8.2, this is third problem. We completed second problem. Here the information is telling that this problem is a girl of height 90 centimeter. A girl of height 90 centimeter. This girl height is 90 centimeter. Is walking away from the base of the lamp post. This is walking away from the base of the lamp post. See now, my dear students, this problem, a girl of height 90 centimeter and the lamp post height is 360 centimeter, that is they given that 3.6 meters, right? 90 centimeter is walking away from the base of a lamp post at a speed is equal to 1.2 meter per second, like this, right? If the lamp post is 3.6 meter above the ground, find the length of her shadow after 4 seconds, right? Very good. For 4 seconds, 4 into 1.2 is what the distance, that is now 4.8 meters, like this is what 4.8 meters, right? Fine. This is what we have written. Now her shadow is nothing but BA. This is what we require to find, right, my dear students? This is third problem in 8.2 exercise in similar triangles, right? How we will do, my dear students? Now triangle ABC is similar to triangle ADE. How means, you know, my dear students, this is actually 90 degrees and this is 90 degrees, right? That is fact. And you know, this angle equal to this angle and this is common angle by AA similarity. By AAA similarity, you can say that they are similar because here this angle equal to this angle. Once they are perpendicular means what? These two lines are parallel. That means their corresponding angles are equal. Okay, and this by AA similarity. Then what you know actually AB by AD, right? This is equal to, right, my dear students, BC by DE. That is equal to AC by AE, like this. Now AB is what now here? X by X plus 4.8 is equal to BC by, right? This is what? 4.8 meters. 4.8 meters means actually we convert everything into centimeters. Then we will get this 4.8 as 480 centimeters, like this, right? This is also will convert now, okay? 90 by 360 you are having here, of course. So once we convert this into, okay, this 4.8 we will convert into, right, into centimeters. Then next this is 480 centimeters, like this, right? This is equal to AC by AE. That we don't want. Okay, well, let us take these two and we'll try to find X value. Then we will be getting this. Here 9 ones, so 9 fours. That means 4x is equal to x plus 480, like this. Now 3x is equal to 480. X is equal to 480 divided by 3. 3 ones, 3 sixes, right? 160 we have got here, like this, right, my dear students? Therefore, x is equal to 160 centimeters, like we have got x equal to 160 centimeters, our shadow length. That means x is equal to 1.6 meters, like this, right, my dear students? How we did this problem, you see, my dear students, such a beautiful way we have got this particular problem, right? Now see this particular problem, the third problem, my dear students. This is fourth one in our material, that means sorry, in your textbook, similar triangles, right? How you do this particular problem is CM and RN are respectively the medians of triangle ABC and triangle PQR. Prove that triangle AMC is similar to triangle PNR and CM by RN equal to AB by PQ. Third one, triangle CMB is similar to triangle RNQ, right? You see, my dear students, how we are going to do this particular problem. CM and RN are respectively the medians of triangle ABC and the triangle PQR. Let us take here triangle ABC here like this and the triangle PQR here like this, right? ABC and PQR like this. Once you have taken like this, okay, CM and RN are the right? We will take otherwise like this. Fine, no problem. Here we take C, right? AB. How it is given like this? CM is, this is what the median like, and right. Next, what we have here is right, RPQ like this. RPQ like this. RN is what, another median like this. CM is okay. CM and RN respectively the medians of triangle ABC and triangle PQR. Now we need to prove that triangle AMC is similar to triangle PNR like this, and CM by RN is equal to AB by PQ, and triangle CMB is similar to triangle RNQ. It's a very important problem, my dear students. How we are going to deal this one is find CM and RN respectively the medians in these two triangles they have given, right? Okay, they given that respectively. Yeah, fine. And one more thing that they given in this problem, triangle ABC. This ABC is similar to triangle PQR. That is what they given first. Okay, this is first. It is there like this. Triangle ABC is similar to first triangle PQR. From that, okay, we need to prove these all the things. Now see how we are going to prove. Once triangle ABC is similar to triangle PQR, you see, my dear students, what we are going to have, AB by PQ is equal to, right? You know that their corresponding sides will be in the same ratio. AB by PQ is equal to, you are going to get AC, I can write even, okay, AC by this, AC by, we can write it as PR like this, right? Wonderful, right? Wonderful. Now, yeah. And this is equal to, okay, once they are similar, and I can say that their corresponding angles are equal, that means angle A equal to angle P also, right? Wonderful. Okay, angle A equal to angle P also. Now AB I can write it as 2 into AM like this, 2 into AM divided by 2 into PN. I can write like this, 2 into PN, because N is midpoint. Now 2 will cancel. This is equal to now AC by PR like this, their corresponding sides, and the included angle here, angle A equal to angle P. Here you consider now these two triangles, my dear students, AMC, this triangle, and PNR. In this, you got AM by PN is equal to AC by PR, and angle A equal to angle P. SAS similarity. Therefore, by SAS similarity, here you see, my dear students, by SAS similarity, right? Sides, two sides and their included angle. By SAS similarity, what you are having is triangle, right? AMC, triangle AMC is similar to triangle PNR like this, right? Wonderful. That means we got the first one like this, right? Wonderful. Once triangle AMC, here my dear students, triangle AMC is similar to triangle PNR, my dear students, here, right? What you know, they are asking the second one, CM by RN is equal to AB by PQ. That is obvious, because, right? Why that is obvious means, once this is true like this, what we know, AM by PN is equal to, once they are similar, what you know is MC by NR or CM by RN like this, and this is equal to AC by PR like this, AC by PR. Once you know, actually they given that these two triangles are similar, that should be given in the problem. That means their corresponding sides are in the same ratio. That means AC by PR, that is equal to, you know already that other sides, AB by PQ, right? And that is equal to CB by, right, CB by RQ. Because since these two triangles are similar, okay, once you know that AC by PR means AC by PR equal to AB by PQ, and that is equal to CB by RQ like this. Okay, now that implies what you have got, CM by RN is equal to, right, AB by PQ, AB by PQ. Such a wonderful way you have got the second one like this, right? Now The third one, you need to prove that CMB is similar to triangle RNQ. That is very obvious. Why it is obvious means, my dear students, we know that for third one, angle B is equal to angle Q. This is what included angle. And also you know that right, AB by PQ, this is equal to, okay, CB by, right, RQ, like this. AB is nothing but what? BM, that is 2 times of BM divided by 2 times of NQ. This is equal to CB by RQ, like this. And you know that angle B equal to angle Q, right? That means, you see, my dear students, here MB by NQ and included angle B equal to angle Q. How you got angle B equal to angle Q? Because these two original triangles are similar, then their corresponding angles are equal. Okay, wonderful. Therefore, now two sides and included angle. Therefore, by SAS similarity, you can say that very nicely, triangle CMB is similar to triangle RNQ. Okay, such a wonderful way you have got the third result also, my dear students. See how beautifully we have got these problems, right, my dear students? Please observe. Now you see, my dear students, this particular problem, what we have here, the fourth one, diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at a point O. Let us draw the diagram here like this. We are having here like this, right? You have that AB parallel to DC, ABCD like this, AB parallel to DC like this, right? They intersect each other at O like this. If they intersect each other at O like this, show that OA by OC is equal to OB by OD like this. OA by OC equal to OB by OD. That is what we require to prove, my dear students. How we are going to achieve this, right? That's fine. These two are parallel here like this. Once they are parallel, now we need to prove OA by OC equal to OB by OD. Let's see, my dear students, here if you consider these two triangles OAB and OCD, these vertically opposite angles are equal, and this angle is equal to this angle because alternate interior angles, because these two lines are parallel like this. And here also this angle equal to this angle, right? Now therefore, by AAA similarity, we can say that very nicely triangle, okay, AOB is similar to triangle. Here angle A means what? Angle C. That order is very, very important. That order. Here angle A is angle C. And angle O is angle O only. And B is nothing but D like this. Triangle AOB similar to triangle COD. That implies, my dear students, AO by CO is equal to, right? AO by their corresponding sides are in the same ratio. AO by CO is equal to, you need what? OB by OD, right? We got that. That is what you require to prove. Such a beautiful way we have got this particular problem, right? You see, my dear students, very simple way you have got this problem, right? Now we have another very, very important problem, a star marked problem. You see, my dear students, we got here something like AB. See, this is BD, right? You are having AB is perpendicular to this BD. And PQ is also perpendicular, CD is also perpendicular. They given that this length is X, this length is Y, this length is Z, and this length is Y. You need to prove that 1 by X plus 1 by Y is equal to 1 by Z, right, my dear students? It's a very nice problem. Let us try to get how we are going to achieve this problem. Let us observe. Okay, my dear students, wonderful, fine. Now, how we are going to do this particular problem? You see, my dear students, you know that right, what you know is fine. We know that triangle, if you take right, this triangle BPQ is similar to triangle BCD like this, because this, okay, here this is 90 degrees, here 90 degrees, this angle equal to this angle, because these two are perpendicular to the same line means they are parallel, and this is corresponding angles by AA similarities, right? Once this is true, my dear students, what you know is BP by BC, right? This is equal to PQ by CD. that is equal to, right, BQ by BD, like this you know that. And PQ is here what, Z by CD. CD is what, Y. Z by Y is equal to BQ by, right, BQ by BD, like this, right, BQ by BD, like this. This is what we are having, like this, right, my dear students. It is not BQ by BD, like this. Wonderful. Let's call it as equation number 1. Fine. Now in the same way, we have here triangle, right, this one DPQ, triangle DPQ is similar to triangle DAB, like this, DAB. Wonderful. Once they are similar, how? The same thing here also. DPQ, here 90 degrees, here 90 degrees. This angle equal to this angle and common angle by AAA similarity, like this. AAA similarity. Now from this DP by, right, you know that DP by DA, this is not useful to us. From that now PQ by AB you are having here, of course. That is equal to DQ by DB, like this, right? Now PQ is what, Nana? Here Z by AB. AB is what? X. This is equal to PQ. Okay, this is what, DQ by DB, like this. Wonderful. Now this is what you call, you take equation number 2. Now equation 1 plus equation 2. Now this is BQ by BD plus DQ by BD, that is equal to, you are having here, right, if you add these two, Z by Y plus Z by X, like this. Z if you take common, 1 by Y plus 1 by X. And you see, my dear students, here BQ plus DQ, BQ plus QD or DQ, that is nothing but BD. Now BD by BD, that is 1. 1 is equal to, you have got Z times of, right, that is 1 you have, that is equal to Z times of 1 by X plus 1 by Y. From this you can say, my dear students, Z if you transfer that side, 1 by Z is equal to 1 by X plus 1 by Y. Such a beautiful way we have got this particular problem. Please observe, my dear students, right? Now see here, my dear students, this is a construction. With this construction you are in a position to do the constructions of any other thing. We want to construct a triangle shadow similar to the given triangle ABC with its sides equal to 5 by 3 of the corresponding sides of triangle ABC, right, my dear students? See how we will do clearly, let us discuss. Now we are going to construct a triangle which is similar to the original triangle, whose sides are 5 by 3 of it. 5 by 3 means what? More than one time, like that. 5 by 3 means more than one. That means what we are going to do, the triangle, construct the triangle which is bigger than the given triangle, like that, right? How we are going to do? With the given measurements, my dear students, first you draw the triangle with the given measurements. Suppose you are having here, okay, we will draw the triangle like this. You see, my dear students, I will explain very neatly here. This is what the triangle you are having, something like ABC. Wonderful, like this. Now we want, this is what the given triangle. We want a triangle which is 5 by 3 times of the corresponding sides of triangle ABC. That is what that means. We are going to get a bigger of it. Suppose they ask 3 by 5 means which is lesser than the original triangle. Both cases let us discuss. First let us discuss 5 by 3 of it. How we are going to do, you see, my dear students. Okay, fine. First step 1 is draw the triangle. Step 2 is nothing but draw an acute angle to this B, acute angle to B, and divide that into 5 equal parts, like this. 5 by 3 is there. That's why what you do is, my dear students, you divide that into 5, 1, 2, 3, 4 and 5 equal parts. Now this is B1, B2, B3, B4, B5, 5 equal parts you do. Right, my dear students? Wonderful. Once you do this thing like this, my dear students, now what we will do is, right, now what we do is you just join B3 to C like this. Next, you extend this. We extend because we want bigger triangle than our original triangle. From B5, you draw a line parallel to B3C. You draw a line parallel to B3C. Now you call it as some C dash, right? Like this. Now you extend this like this. You extend this, my dear students. You see here, you extend like this. Now from C dash, you draw a line parallel to CA like this. Right, this is what you are having here. This you call it as some, because A dash, let us write this as some A dash. Now A dash B C dash is the required triangle whose measurements are 5 by 3 of the original triangle ABC. It's a very simple way you have got. You see, my dear students, step 1 is draw the triangle ABC. Step 2 is draw an acute angle with CBC. Divide into 5 equal parts. We want 5 by 3 of it. Step 3 is what? You join B3C. Step 4, you join B5C dash, which is parallel to this, right? Fine. Next, you draw C dash A dash parallel to CA, which is meets the extended portion. Now you have got A dash B C dash is the similar triangle to the original triangle ABC, whose measurements are 5 by 3 of the original triangle ABC. That we can easily verify, my dear students. You see here, right? Here you see, when we said that these two are parallel, this angle equal to this angle and this angle equal to this angle and this. That means triangle, right? BB3C is similar to triangle BB5C dash by A similarity, like this, right? Wonderful. That means we see, my dear students, BB3 by, otherwise, right? Yes, we can take, once they are similar means, yeah, we can take like this, BB3 by BB5. This is equal to BC by BC dash, right? Wonderful. BB3 is actually 3 equal parts. This is what actually 3 equal parts. This is 3x, something like, if you take this as x, each equal part, if you take it as x. 3x by, you are having here 5x. Now this is 3 by 5. That means now BC dash by BC is equal to 5 by 3. Now see, my dear students, BC dash, this by this is 5 by 3. Next, if you take this triangle and this triangle, these two are similar. Why they are similar? Now this angle equal to this angle equal to this angle, and this is what their corresponding angle. Therefore, by A similarity, I can say, by A similarity, what we can say, triangle ABC is similar to triangle AB dash C dash. From that, what we will get, BC dash by BC is equal to, right, my dear students, AC dash by AC, that is equal to AB dash, right? Even, you see here, my dear students, sorry, here what we are getting is BC dash by BC is equal to CA by C dash A dash by CA is equal to, right, you are going to get A dash B by AB, A dash B by AB, that is equal to 5 by 3, right? You have got now these sides, these corresponding sides are 5 by 3 times of the original triangle. This is the proof how you will be doing, my dear students, right? Now we have constructed in this way, right, my dear students? You understood? It's a very simple how you have constructed constructions. Each and every step you write clearly, and this is the proof what we are given to you, right? Now the same thing, instead of 5 by 3, my dear students, we want 3 by 5. How we are going to construct this, you please observe. Okay, now I am having here, this is what the triangle, my triangle, I am having like this, my dear students, A, B, C. I want now 3 by 5, a triangle which is similar to this, and 3 by 5 of corresponding sides of original triangle. How I am going to do that, you see now, my dear students, right? Fine. How we are going to do this? Now you see, my dear students, you take, fine, here also you take, divide it into 5 equal parts like this. So this you call it as B1, B2, B3, B4, B5 like this. Now you join this B5C. Now you join B3 which is parallel to B5C, you call it as some C dash. Now you join A dash like this, right? You parallel to this, you join like this, right? Now you have got BC dash A dash is similar to BCA, whose measurements are, and these are similar because they are parallel, means these are similar. Once they are similar, you see my dear students, what we are going to get, that is the same way BB3 C dash is similar to triangle BB5C. That means BB3 by BB5 is equal to BC dash by BC. That is equal to actually 3x by 5x. That is 3 by 5 of it. Now these two triangles are also similar, right? Same way. Once they are similar, y means this angle equal to this angle, this equal to this, and this is one what we are having here now like this. Now BC dash A dash is similar to triangle BCA. Therefore you are getting here, right, what my dear students, BC dash by BA BC is equal to C dash A dash by CA, this equal to BA dash by BA, that is equal to 3 by 5 like this. Therefore you have got 3 by 5 of it, and this is the required triangle, which is 3 by 5 of the measurements of this triangle. In this beautiful way we will be getting now 3 by 5 of it. Thank you very much. Thank you my dear students.